Hi everyone, welcome to the Earth Science Regents Review podcast series created by the Hommocks Middle School Earth Science Department. Today we're going to be talking about stars. Well, stars are going to be important because they produce a tremendous amount of energy. Our sun, which is a star, produces the energy that's required for life on the planet. So we say that they are self-luminous. Stars are going to be important because they make their own energy through the process of what we call fusion, which we'll get to in a second. Stars are also important in the sense that they make up galaxies. There are billions of stars within each galaxy. Okay, and our sun is one of the billions of stars within our own galaxy called the Milky Way. Now, the process of fusion is a fairly simple one in the sense that hydrogen is going to combine with itself to make helium. That process right there creates a tremendous amount of energy. Now, the fuel for the sun is going to be the hydrogen. So our own sun has enough hydrogen left in it for another 4 to 5 billion years worth of energy. So here's the process of fusion that's actually taking place in the sun right now as we speak. So you get your hydrogen atoms, specifically 2 of them, are going to combine together. They're going to be attracted to each other. You'll see them fusing together. Fusing means coming together. Once that helium atom is released, a tremendous amount of energy is created, and that's what gives us our energy from the sun. Okay, so all stars go through a life cycle. These life cycles can take billions of years to go through, but there's 2 factors that are going to influence how a star is going to live its life, either by mass or by size. Certain stars, are going to take a specific life cycle. For instance, our sun. Our sun is an average star. It has an average brightness, it has an average temperature, has an average color. So our sun is going to take this specific path, and what's going to happen to our sun in about 4 to 5 billion years is going to turn into a phase called a red giant. Now, when you look at the life cycle, you see that there's an upper path and there's a lower path. The upper path of this life cycle is going to be the path that our own sun is going to take. You see an average star turns to a red giant. So there is a chart in your reference table called the star chart. It's on page 15, and it helps organize our stars. Now, stars are classified by 3 factors. They're organized by luminosity, which is brightness, color, and temperature. So you'll see here that the vertical axis on the left-hand side is your luminosity. You find our sun right in the middle of the main sequence. You follow to the left, has a luminosity of 1. Anything above the sun is going to be brighter than the sun. So you see the numbers 10, 100, 1,000, 10,000. That's how many times brighter a star is compared to our sun. The opposite of that is how many times dimmer a star is. So any star below our sun is going to be dimmer. So you see the numbers 0.1, that's 1/10 as bright, 0.01 is 1/100th as bright, and so on. The vertical axis is luminosity. The horizontal axis, there's 2 scales, surface temperature and color. Depending on the temperature of the star is going to indicate what color it's going to be. You see on the right hand side, small stars on the bottom, large stars are at the top. And if you go to your main sequence section, you see the sun is right directly in the center. Average star. Also on page 15 is your solar system data. And you can see that the sun is at the very top there. The sun is part of our solar system. And it gives you some information about the period of rotation, the equatorial diameter, the mass compared to Earth, and its actual density. All right, that's it about stars.